Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. I'm Jeetendra Dixit. Here is my profile. Just a moment, let me check whether I'm live or not. So, hello Raghav. Getting my voice perfectly? All right. Okay, so before we begin, let me tell you about the Unacademy subscription. So, as you know, it is India's largest online learning platform, and if you are preparing for IIT-JEE, then you can have two types of subscription. One is Plus, another is Iconic subscription. So in Plus subscription, you can access the daily live classes of all the educators who are teaching on an academy. You can follow their courses. You can follow educator of your choice. So this is unlimited access which you get on the platform once you buy Plus subscription. Now, these are the charges of Plus subscription. You can subscribe for 1 month, 3 months, 6, 12, 24 months. Okay. So 12 months price is 38,500 and 24 months it's 56,000, and you will get 10% discount using the code JEET1. Use this code and you'll get instant 10% discount. All right. So final price will be 36,000, 34,650 and 50,400. All right. The next is Iconic subscription. So you can also buy Iconic subscription. In this, you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout your preparation for top exams. Your test analysis will be done in a personalized manner. Your personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized. Bi-weekly reviews will be given, highlighting your progress. All right. And these are the subscription charges for you. You can subscribe for 6 months, 12 months, 24 months. Okay. And of course you'll get 10% discount using the same. Use this code JEET1. All right. Or this is Unacademy's learning app which you can download from Play Store, and after downloading it you can start your journey with Unacademy. You can attend special classes, that a lot of content you get for free, or you can use the same code JEET1 to access the free content as well. All right. So we were doing straight lines and I'll continue straight lines. So GI is not there, huh? Raghav. Okay, GI is there. She's okay. Good evening. Good evening. Good. So we are starting family of lines, huh? Actually, this was an important topic, so that's why the time was different today. I was not sure whether you guys will be able to attend it. Family of lines. Good, good. You joined. Family of lines. So what is family of lines? See, if uh, family means they have something in common. So now you're going to you'll see this word family of curves, family of circles, family of parabolas, family of any other curve. That means they have something in common, like circles having same center, concentric circles. You can call this as a family of circles. Okay, what is common in all these circles? They have same center, but radius is changing, right? Radius is changing, so you can call this family of circles. Similarly, if you draw lines and say lines are parallel lines, okay, lines are parallel lines of slope, suppose 2, slope is say 2, then the general equation of this family is going to be y is equal to mx, y is equal to, sorry, 2x. So you can call it family of parallel lines, okay, family of parallel lines. And slope is given, suppose 2, so you can write the general equation of this family as y is equal to mx, y is equal to 2x plus c. This represents the general equation of this family. If you change C, the line will be different, but it will remain parallel. Okay, all these lines will be parallel of slope 2. Oh, okay. All right. So, are you understanding this word family of curves? Okay. What is the meaning of family? Family means they have something in common. All right. Now, what we do, what are we going to do here? See, we can call this family of parallel lines. This family of parallel lines. But mostly equations which we do are basically like family of lines concurrent at a point. So suppose all the lines are passing through a point, the kind of family, okay? So all these lines are passing through this point P. So a family of concurrent lines. Family of concurrent lines. So we are going to do this family of concurrent lines. And family of circles, we all form a family. You are the part of an academy's family. See, if I give you 2 points, then all the circles passing through 2 points will be family of circles passing through these 2 points, okay? So this family we are going to study in circles. Family of circles passing through two fixed points, okay? So this family we are going to study in circles. And here we are going to broadly, this will discuss mainly this family of concurrent lines, okay? So how to write this family of concurrent lines? Let's see that. Family of concurrent lines. See, suppose we need to write the equation of a family, equation of, so first we are learning how to write the equation of family passing through a fixed point. Then we will see if equation of family of lines is given, then how to find that point where these lines are concurrent, okay? So two ways. First, we are going to form a family when a point is given, family of lines passing through. So basically, we need to write a general equation, okay? And that equation for all values of the, because that will be a general equation. So there will be some parameter, like in this equation, you can see C is a parameter, right? C is a parameter. If C varies, then this equation will vary and it will represent different lines. So whenever you are writing a family of equation of family of curves, then it will involve some parameters in its equation. It may be one, there might be one parameter, there might be two parameters as well, okay? Because if this values of those parameters will change, then curves will also change. For different values of those parameters, you'll get different members of that family, you can say. Okay. So first we are going to write the equation. Okay. Equation of family of lines. Family of lines passing through. Passing through point of intersection. Now point is not given, two lines are given. Point of intersection of lines a1x plus b1y plus c1 is equal to 0. Say this is line L1 and L2. Second line is given a2x. These are fixed lines. So see what does this represent? We need to write a family of lines passing through the point of intersection of two given lines. Okay. So I'm going to tell you a general term. Suppose you have two curves. S1 is a curve, fixed curve. S1 and S2 is equal to 0 are two fixed curves. Fixed curves. And also intersecting. intersecting at 1 point, 2 point, 3 points, 4 points. Okay, कितने भी points हो सकते हैं. So suppose these two curves are given which are intersecting each other at suppose let's say 2 points, okay, A and B. We need to form a family of curves. Then family equation of this is a general thing which I am telling you. It is true for all lines, straight lines, line, circle, 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 parabola, circle, parabola, parabola. You can take any two curves. Okay. So how to write the equation of family of curves passing through all the points of intersections of two given curves. Okay. दो given curves के सारे points of intersection से पास होने वाले curve की general equation कैसे लिखते हैं? This is what we are going to learn. Okay. So of family equation of family of curves passing through. Now this is statement is important. Okay, see it carefully. Passing through all the points of intersection of S1 is equal to 0 and S2 is equal to 0. Okay, is given by, can you tell me now what is this? Equation of family of curves passing through the points of intersection of S1 is equal to 0 and S2 is equal to 0. It is written as lambda 1 S1 plus lambda 2 S2 is equal to 0. Well, lambda 1 and lambda 2 belong to real numbers. Or you can also, if you divide by lambda 1, you will see equation is written like this: S1 plus lambda 2 upon lambda 1 S2 is equal to 0. This you can take another parameter lambda. So you can also write this equation as S1 plus lambda S2. Okay, these two are same thing, first and second. So when you add two curves by multiplying them with some parameters, lambda 1 and lambda 2, then you get a new curve. Okay, you get a new curve, and that new curve, see, this represents infinite number of curves, because if you put lambda is equal to 1, it will be S1 plus S2 is equal to 0. If you put lambda is equal to 2, it will be S1 plus 2 S2, right? So for different values of lambda, it will be a different curve. Okay, but all these curves, what I'm saying, this, listen to this carefully. All these curves for all values of lambda, S1 plus lambda S2, always passes through the points of intersection of S1 and S2. That means A and B. Can you show this, that this curve is passing through A and B? Yeah. Can we show this? S1 means S1 x comma y. It's an expression of xy, plus lambda times of S2 means S2 x comma y is equal to 0. Okay. So if this curve is passing through x1 y1, so x1 y1 must satisfy this equation for all values of lambda, right? We are saying that this curve number say 1 is passing through x1 y1, then this is x1 x comma y is equal to 0, and this is S2 x comma y is equal to 0. Can somebody explain this? Yes, very true, Raghav. X1 comma y1 is in point of intersection of S1 and S2 both, right? So it will satisfy both equations. If I put x1 y1 in S1 curve, so we can get S1, we'll get S1 x1 comma y1 will be 0. Similarly, S2 x1 comma y1 will be 0. So similarly, if I put x1 y1 in this, I'll get this S1 x1 comma y1 plus lambda times of S2 x1 comma y1, and this is 0 and this is 0. So it is 0 is equal to 0. That means x1 y1 will satisfy this point, this curve, no matter what is the value of lambda. So this new curve is passing through A and B. Okay, this new curve is passing through A and B. Hello, Manas. Got this point? Got this point? Is this okay? So when you add two curves, suppose you have two equations, two parabolas, they are intersecting. Now, but let me make this clear. Okay, now listen to this point carefully. S1, suppose S1 is a journal curve, 2-degree curve, 2-degree curve. S2 is also a 2-degree curve. So this you learn later, that it's a 2-degree curve can represent a circle, can represent a parabola, it can represent ellipse, it can represent a hyperbola. So when you add 2-degree curves, suppose a parabola and another is also a parabola representing two parabolas, S1 and S2. And when you add them, S1 plus S2, yeah, S1 plus 2S2 or S1 plus 3S2, then you might get a parabola or you might get a circle as well. So it is not necessary that if you are adding two parabolas, then you'll get a parabola only. So if you're adding S1 plus lambda S2, it is a curve. It is a curve which passes through the points of intersection of S1 and S2, but not necessarily of the same type of S1 or S2. मतलब अगर एक S1 circle है और S2 parabola है, then by adding them, it's not necessary that you'll get a curve which is a circle or a parabola. You might get a line. You might get a line. You might get a hyperbola. Is that okay? Is this point, are you understanding this point? Because 2-degree plus 2-degree will be either 2-degree or linear, and 2-degree can represent any curve, any conic, which we are going to study, parabola, circle, ellipse and hyperbola. Okay. But now let's come back to lines. Line means equation of line is linear. This type of equation, ax plus by plus c is equal to 0. This equation always represents a line. This is a linear expression in x and y. So linear expression of x and y always represents a line. Okay. And when you add two linear expressions, that means you are adding two lines, then you'll get a linear equation again. So that linear equation will again represent a line only. It cannot represent a parabola. It cannot represent an ellipse. It cannot an ellipse. It cannot represent a hyperbola. It cannot represent a pair of straight lines. It will represent a line only. So if you are adding two lines, if you are adding equations of two lines, it will represent only, if you are adding two lines by multiplying them with some parameter also, then you'll get a line only. That's why we call it family of lines. Okay. See, in the previous one, I was saying family of curves. If you're adding two parabolas, suppose you have two parabolas and you're adding them S1 plus lambda S2, then you can't call a family of parabolas, but because it can be a circle also. In that family, there might be some members which are circle. There might be a line. Okay. So when you write S1 plus lambda S2, you'll have to say it is representing a family of curves passing through the points of intersection of S1 and S2. But when you're adding two lines, you can call it family of lines. It's not necessary that you should call it family of curves, because you know that every member. Okay, so let's come back to here. Equation of family of lines passing through the point of intersection of this and this is given by lambda 1 L1 plus lambda 2 L2 is equal to 0, or you can say L1 plus lambda L2 is equal to 0. All right. So this represents the family. This is family of lines. Okay. This is always a line. This is always a line for any value of lambda. Okay. So if this is say L1 and this is say L2, then these lines are basically passing through the points of intersection. So two members were already given. Now we have got a general equation which will represent all the lines passing through the points of intersection of L1 and L2. All right. So I hope you are getting this point. Huh? Akshay, today is not a doubt session. Today will be a discussion session of straight lines. I'll discuss some questions of straight lines. Okay. Now see how to use it. Okay, now suppose you need to find let's use this. Okay, find the point of intersection, point of no, sorry. Although this question, using family of equations in this particular question is not very, it will reduce your calculation or something like that. It won't. Find the, but we are just learning how to use it. Find the equation of line passing through the point of intersection. Now I'm writing a new question. Suddenly a new question came in my mind. So in this it will help. In this the calculation will help. Find the equation of line passing through the point of intersection of ax plus by plus c is equal to 0 and bx plus ay plus minus c is equal to 0, all right, and origin and 0. Okay, so suppose we need to find the equation of a line passing through the points of intersection of these two lines in which numerical values are not given, because if numerical values are not given, then finding point of intersection is slightly lengthier. Okay, basically if numerical values of a, b and c are given, then you can find the point of intersection easily. And once you get the point of intersection, you can join it with origin. Now you can write the equation of a line passing through the point of intersection which you have got by solving them, and the other point which is given. So you can write the equation of line joining 2 points. But in this, you need to solve this question without finding the point of intersection. Okay, so you can do it. So what will I write? I'll write family of lines passing through the point of intersection of line number 1 and line number 2. 1 and 2 is given by ax plus by plus c plus lambda. A, b, c are fixed numbers, plus lambda times bx plus ay minus c is equal to 0. All right, are you guys getting it? Okay, we have written this. Now we need see, these are line number 1 and line number 2. Line number 1 and line number 2. This is origin. We need this line. I mean, we have written the general equation of line which is passing through the point of intersection of 1 and 2, but we need this particular member of that family. So how to find that? For that we need lambda. For some value of lambda, it will be this line which will pass through 0. So how to find that lambda? Now that is the question. So to find the lambda, we can use this point, because this line is passing through 0. So let 0 will satisfy this equation. So put 0, in this. Okay, so put 0. So if you put 0, you will get this 0 plus c plus lambda times of 0 plus 0 minus c. Okay, so minus c. So you can see lambda is equal to what? Lambda is equal to 1. All right. Yeah, lambda is equal to 1. That means if we resubstitute the value of lambda, then it will be a now fixed line. It is basically L1 plus L2. So L1 plus L2 is a line which passes through the point. So if just put back the value of lambda, and you'll get a plus b into x plus b plus a into x, and c of course will become 0. And you can see you can write this x plus y is equal to 0. So x plus y is equal to 0 is the line which is passing through the point of intersection of two given lines, and the point of intersection was actually 1, 1. No, sorry, not 1, 1. Something else, I don't know. 1, minus 1 might be. No, 1, minus 1 is not also. Some other point maybe. So we don't need that point actually, point of intersection of 1 and 2. Are you guys getting it? We have got the line belonging to that family, when belonging to the point, passing through the point of intersection 1 and 2, and also passing through origin by using this family of lines. Okay, without finding their point of intersection. It will help a lot in circles. But in straight lines, this concept is very important because sometimes, okay, the second type of question which we are going to do is actually more important. Okay, you guys got it, huh? Now, second type of question is this. Suppose it is given that if lambda belong, the question type of question I'm telling you, which they ask from family of lines. So if lambda belongs to R, when you say lambda belongs to R, that means lambda is a parameter. So if lambda belongs to R, then prove that line represented by 2 plus lambda into x minus lambda minus 3 into y plus 4 minus 2 lambda is equal to 0 passes through a fixed point. Passes through a fixed point. See how to do it. If lambda belongs to R, then prove that line represented by this equation passes through a fixed point. So because you can see if lambda varies, then this equation will vary, you know. Now listen to this, whenever he asks this question that prove that this line passes through a fixed point, this question will come in each chapter, in circles, in ellipse, in hyperbola. Okay, everywhere you'll get this question. Prove that tangent of this circle passes through a fixed point. That means it is belonging to the family of equations. How to solve it? Just show that this equation is representing a family of lines passing through the point of intersection of two fixed lines. We need to show that this equation represents a family of lines passing through the point of intersection of two fixed lines. And how to do that? How to do that? We know that any equation of type L1 plus lambda L2 or lambda 1 L1 plus lambda 2 L2 is equal to 0 represents a family of lines. Okay? We know that. So we are going to express this equation in that particular form. So how to express it? Just separate the terms of lambda and rest of the terms separate. Okay, so 2x plus 3y plus 4. Okay, I've written these terms separately plus lambda times of remaining terms. Lambda times of x minus lambda times of y. So lambda is common, so minus y minus 2 is equal to 0. Are you getting it? This is very direct, but let me explain it first. So this is line L1 and this is line L2, right? So can you see this? This is actually passing through. This is actually passing through two fixed lines, L1 and L2. This is written in L1 plus lambda L2. You can compare it with L1 plus lambda L2, right? And then we can solve these two equations. 2x plus 3y plus 4 is equal to 0 and x minus y minus 2 is equal to 0. All right. And to solve it, just multiply it by 3 and add. So you'll get the point. So that point is 5x and minus 6 plus 4 is 2 minus 2. So 2x is equal to 2 by 5. If you put x is equal to 2 by 5, so y is going to be minus 8 by 5. All right. So I think this is the point, if I've solved it correctly. You can check that these points are passing through. These points will satisfy this equation as well as this. Obviously, they will satisfy because it is the point of intersection of these two. So if it is satisfying these two, that means these two lines will become 0, and these two lines are becoming 0 means this equation will become 0 for x is equal to 2 by 5 and y is equal to minus 8 by 5. So no matter what is the value of lambda, the given line will always pass through this point. Got it now? Got it? Then I'm going to give you the next question. Got it, guys? All right. Now see this type of question. Prove that ax plus by plus c is equal to 0 passes through a fixed point provided a, b and c are in AP, okay? Also find the coordinates. Also find the coordinates of the point. Solve it. Tomorrow there will be a doubt class, Akshay. Don't worry. Tomorrow will be a doubt class. You have a lot of doubts, huh? Bring doubts from triangle. That will be interesting, okay? You asked doubts. Yesterday you were asking point of intersection of two lines. It was very boring and very simple for others. Bring doubts from geometry, yeah. That will be interesting. You can bring doubt because you're intense, so you can ask circle geometry, triangles, okay? Then others will also take interest in your doubts. You're saying geometry is like memorizing things? Huh? Geometry is mugging. No, that is not the right thing to say. Geometry is very interesting. Geometry is very interesting, Mr. Akshay. It's a very important part of pure mathematics, algebra and geometry. If you don't do it properly, then it is like that. Then students actually start disliking. हाँ, ज्योमेट्री में दिमाग लगाना पड़ता है. When I was in 10th class, that was my favorite topic. It is still, but now there are a lot of other topics also. But when I was in 10th class, geometry was my favorite topic. Okay, guys, got it? That point, yeah, G, 1 comma 2, yeah. Very good. How did you get it? How did you solve it? Raghav, how did you solve it? Can you just explain how did you solve it? Jia, did you solve it like 2b is equal to a plus c by putting 2b is equal to a plus c? So in this equation, ax plus a plus c by 2 into y plus c is equal to 0. Solving like this, a is equal to, okay, okay. पिछले क्वेश्चन जैसा. So now you solved it like a into x plus 1 by 2 plus 1 by 2 y plus 1 into c, right? So now you can see this is line number 1 and this is line number 2. Okay, it is written like L1 lambda 1 L1 plus lambda 2 L2. You can compare with this, huh? So x is equal to minus what were the points you were getting? 1 comma 2. 1 minute. Have I done some mistake? Okay, sorry. Coefficient of a is x plus y by 2. Coefficient of a is x plus y upon 2, not 1 by 2. Plus coefficient of c is 1 by 2y plus c plus 1 is equal to 0. Wait a minute. You are getting both points positive, 1 comma 2. One of the point will be negative actually. See, from this, if you put 0, then y upon 2 plus 1, Raghav, you haven't got the answer. Y plus 1, y by 2 plus 1 is equal to 0. This is the one, this is second line, and this is first line, x plus y, yani 2x plus y is equal to 0 basically, right? So from this you'll get y is equal to minus 2. So if you're getting y is equal to minus 2, this is the line, right? Y is equal to minus 2, horizontal line. And if you put y is equal to minus 2 in this, you'll get x is equal to 1. So this is the point of intersection of 1 and 2. 1 comma minus 2. 1 comma minus 2. Okay. So basically, there were 3 parameters in this equations. 3 parameters were involved. But a linear relation was given between these 3 parameters. So what you can do, you can remove one of the parameter. And after removing one of the parameter, it will be an equation involving 2 parameters. So in those 2 parameters, you can write the equation in lambda 1 L1 plus lambda 2 L2 form. And after that, you can compare L1 and L2 and solve them to find the point of intersection. To find that point where all these lines are concurrent. But there's a trick. There's a shortcut also. Shortcut. What is that shortcut? See, I'll tell you that. So if you have relation, see, line was ax plus by plus c is equal to 0. This was the line. And the linear relation which was given in a, b and c is basically a minus b into 2 plus c is equal to 0. So you can compare these two. How would you compare? Coefficient of x is 1 here, right? Compare coefficient of x. First you should make the constant term same. You can see c and c are same. It should not be c in the first equation and 3c in the second equation. If it is 3c, then you'll have to divide by 3. So now you can compare because you can see the c are same in both the equations. So other 2 coefficients of a and b also must be same. So by comparing these two, you can say x is equal to 1 and y is equal to minus 2. Directly you can answer it. Have you got it? Both of you? Jia, you got it now? Okay. Then see, if I write suppose the line was given like this: ax plus by plus c is equal to 0, and a, b, c are parameters. And given that, prove that the question is same. Prove that this line passes through a fixed point. Find the coordinates of that point. Given that 2a plus 3b minus 2c is equal to 0. All right. Now ABC in the previous question, ABC were given in AP. Now this relation is given 2a plus 3b minus 2c is equal to 0. Now how to find the coordinates of that point easily? Can you compare now? Compare. You can do two things. You can replace C by in terms of A and B and then do the whole process, or you just compare. The above equation is written linear in ABC and the second equation is also in linear in AB and C. Just compare the coefficients, you'll get X and Y. Compare and write the coefficients. It's the same question. 1 comma 3 by 2. Gia, what's your answer? Minus. You forgot minus, huh? So you need to divide it by minus 2, okay, first of all. So if you divide it by minus 2, then it is going to be minus A, minus 3 by 2B and plus C, okay. So rewrite this equation in this form and then compare it with X into A plus Y into B plus C is equal to 0, right? Then you can compare X is equal to minus 1 and Y is equal to minus 3 by 2. So this is the point, okay. If you put this point in this equation, you will get this relation which is given 0, all right. So that means it will be 0. Okay, the last question, and then we will. Last question is this: prove that ax plus by plus c is equal to 0 passes through a fixed point. Provided this one. Also find the possible coordinates of the point. Also find the possible coordinates, okay, of the point. One by three, comma two by three. Same, huh? All right. Yes, so basically now it's a 2-degree relation, but from this 2-degree relation, you'll have to find linear, otherwise you won't be able to solve it. So how to do it? Now you can see there's a perfect square, so they can give any 2-degree relation or maybe 3-degree also. You'll have to factorize it. Factorize it to get a linear relation in A, B, and C. In this case, it is very simple. You can see A square plus 4B square minus 4AB, club them, is equal to 9c square. It will become a perfect square. So this a minus 2b the whole square is equal to 3c the whole square. Now you can write a minus 2b, uh, a square is equal to b square, that means a is equal to plus minus of b. So either a plus b is equal to 0, so plus 3c is equal to 0, or a minus 2b minus 3c is equal to 0, right? You can divide 3 in this, so it is 1 by 3 into a minus plus minus 2 by 3 into b plus c is equal to 0. And similarly you can write this relation as well, like 1 by minus 1 by 3a plus 2 by 3b and plus c. Okay, now you can compare. So whether this relation exists or the other one, in both the cases line will always pass through a fixed point. Yeah, that fixed point will change according to the relation which will hold. I mean, which is 0, because either first one will be 0 or the second one will be 0. So in any case, the possible points are 1 by 3 comma minus 2 by 3. Either this family is passing through this point or this family is passing through minus 1 by 3 comma 2 by 3. All right. So these are the possible coordinates of point of concurrency of all the lines of this family. You guys got it, huh? You guys got it in the family of lines? The last statement I'm saying, okay? Let's listen to this. Last statement. Where to apply this? See, 9 o'clock say. We are ending now. So uh, today we are doing a family of straight lines, so it's easy for you to figure out, okay, that we need to apply this method. But later when you will be doing circles, ellipse or hyperbola, then how would you figure it out? That, oh, in this question you need to apply family of lines. So for that, this is the statement which I'm going to now say. The statement is this: whenever you need to prove, now listen to this, whenever you need to prove that a variable line, why I'm saying variable, because there will be some parameter in that equation, in the equation of that line. There might be one parameter, there might be two parameters, and there might be three parameters, but in that case, you should know a linear relation in three parameters, okay? Like we are doing here. So there will be a line, variable line, and if it is said that prove that this line passes through a fixed point, this is the statement, okay? Just by reading this statement, immediately in your mind it should come that, oh, this is a question of family of lines. We need to apply family of lines in this question. And after applying it, we can prove, although this line is a variable line, but it will pass through a fixed point. That means it is representing a family of lines. And if it is representing a family of lines, that means it can be expressed, it must be expressed in n1 plus lambda L2 form. All right. We must be able to express the given equation in L1 plus lambda L2 form. So just go ahead and keep doing it. You will be able to express it in L1 plus lambda L2 form, then solve L1 and L2, and you'll get the point. And you can say, yes, this line is passing through a fixed point. All right. So am I clear now? Jia Raghav, clear? Shall we end it now? Okay, no doubts. Okay, then see you at 9 o'clock. Okay, practice session. I have kept easy questions, practice questions today, but good questions, simple questions. Eh? So we'll do practice session and then continue tomorrow. Tomorrow I'll cover angle bisectors of lines. All right, chalo fair. Okay then, bye bye, take care. Thank you.